When you trace the history of like any major technological shift, there's usually this, I don't know, this prevailing illusion of order to it all.
Right, like it was all planned out perfectly.
Exactly. You look back at the Industrial Revolution or the dawn of the internet, and from a distance, it looks like this clean, linear track of progress.
Yeah.
You invent the steam engine, you lay the tracks, the train runs, and everyone just points at the horizon and says, well, there is the future.
But it never actually feels like that when you're in it.
No, not at all.
Right.
When you are actually in the middle of it, living through the friction of that transition, it doesn't feel like a neat timeline. It feels like the track is being built, ripped up, and rerouted every single morning.
Which is pretty much exactly where we are right now.
100%. Stepping into the world of cyber intelligence right now, in mid-2026, is just the ultimate expression of that chaos. We're looking at a landscape that is highly fragmented, incredibly opaque in certain areas, and evolving so rapidly that the underlying physical infrastructure is, frankly, struggling to keep up with the math.
Right. And I mean, that makes this particular moment in the timeline so critical to document. We aren't just watching software iteratively update with, minor bug fixes anymore.
Yeah, we are way past that.
Way past. We are literally watching the foundational operating principles of reality being recoded in real time. The very definition of what constitutes intelligence and how it actually interfaces with physical industry is undergoing this disruptive evolution that completely ignores legacy systems.
Okay, let's unpack this, because our mission today is to cut through all of that noise. We are going on a deep dive into a truly fascinating, highly opinionated, and densely packed manifesto that recently hit our desks.
It is a dense read, for sure.
Oh, totally. It's titled, Where Are We At with Cyber Intelligence?, authored by Professor Guy Lakeman. And to anchor Lakeman's sprawling, and I mean sprawling philosophical and technical arguments, we are pairing his text with a deeply revealing piece of quantitative data.
The El Marina leaderboard.
Yes, the El Marina leaderboard chart tracking global AI model dominance from mid-2024 through late 2025. Now, Lakeman's text is not some sterile, peer-reviewed academic white paper. He is pulling absolutely no punches here.
He really isn't. He's furious.
Furious is a good word for it. The document is highly charged. It's filled with these intense references to big lies, the systemic incompetence of the corporate C-suite, dogmatic belief systems, and what he terms subversive integration.
What's fascinating here is the duality of his approach. Lakeman blends this highly specific objective technological analysis, discussing hardware pivots and parameter architectures, with a fierce, almost visceral social critique.
Right, and I think we need to make something very clear right off the bat.
Absolutely.
To be clear up front, our objective today is not to endorse Lakeman's geopolitical views, his social frustrations, or his specific worldview. We're not taking sides here.
Right. Whether his political leanings lean left, right, or sideways, that's not what we're evaluating. We are here to neutrally examine the mechanics of his arguments.
Exactly. We are going to isolate the technological leaps he identifies, cross-reference them with the El Marina data, and explore the very real global shifts he is documenting. We're separating the emotion from the underlying engine, basically, to see exactly how this machine is operating.
And that engine matters to you, the listener.
Yeah, it really does. Whether you are currently optimizing a local open-weight model on your home rig, or maybe orchestrating complex agentic workflows for your startup, or honestly just navigating an economy where an algorithm might be the sole arbiter of your next career move.
Yeah, the HR aspect is huge.
It's terrifying, actually, but we'll get to that. The point is, this deep dive is going to break down exactly what is sitting inside that smarter-than-human box on the desk.
But before we get into the latent space and the massive parameter architectures, we need to start where Lakeman starts.
In the dirt.
Literally in the dirt. He grounds his entire thesis in the physical, tangible world. He points out that cyber intelligence is fundamentally rewiring things that do not think.
Right, the agricultural sector.
Yeah. He introduces this concept of artificial seasons in agriculture, which entirely reframes how we think about biological production. It's a perfect microcosm for the broader shift he's describing.
Because we tend to think of AI strictly in the digital domain, right?
Yeah.
Generating code, parsing text, making synthetic media.
Exactly. But Lakeman shatters that paradigm by highlighting its role in physical biology. He describes these hyper-controlled agricultural environments where AI doesn't just monitor the conditions, it dynamically dictates them.
It's basically playing God with the weather.
Pretty much. It's simulating entire seasons on a wildly accelerated timeline.
He notes that plants in these specific environments are now grown on a hyper-compressed 5-week growth cycle.
which is just insane to think about.
5 weeks. Instead of relying on the Earth's axial tilt and, our orbit around the sun to dictate a traditional harvest schedule, these AI-managed systems are yielding 10 crops a year.
10
And
crops.
my assumption here is that we aren't just talking about basic automated watering systems on a timer.
Oh, no, not at all.
This has to be highly complex cybernetic feedback loops, right? Systems that are constantly analyzing soil microbiology, adjusting NPK ratios on the fly.
And manipulating specific photonic spectrums of LED light.
Right, to simulate dawn, high noon, dusk, perfectly, minute by minute, just to force the plant's biology into absolute overdrive.
That is precisely the mechanism. The cyber intelligence is reading the real-time metabolic state of the crop. Then it alters the microclimate variables, the humidity, the CO2 saturation, the nutrient delivery, to optimize the biological yield way past natural terrestrial limits.
That's wild.
And if we connect this to the bigger picture, achieving 10 crop cycles annually fundamentally destabilizes traditional global commodity markets.
Oh, I mean, it alters the entire calculus of food security, supply chains, even arable land value.
Right. But running continuous, hyper-dense, AI-orchestrated physical environments like that requires immense, uninterrupted power.
Which brings us to the first massive bottleneck.
Exactly. This introduces the primary technological bottleneck Lakeman identifies, which is the hardware power struggle.
And this is where he draws a huge line in the sand between two competing hardware philosophies. Lakeman acknowledges the titans, your Googles, your DeepMinds, and says, yes, they are making undeniable leaps in intelligence.
Sure, the software is brilliant.
But he heavily criticizes the underlying hardware fueling those leaps. He specifically points to NVIDIA's traditional silicon architecture, and he calls them overwhelmingly energy hungry.
Yeah, he's highlighting the sheer gigawatt demand required to spin up those massive clusters of H100s or B200s.
To run the math, you are essentially boiling oceans to cool the data centers.
It's a massive thermodynamic problem. So Lakeman contrasts this digital silicon reliance with a totally different paradigm that is gaining massive traction right now.
Photonics.
Yes. German development and Chinese productivity are focusing heavily on mass-producing photonic integrated circuits. And the shift from traditional silicon electron flow architectures to photonics is arguably the most critical hardware divergence of the decade.
Can you break down the difference for us? Like, mechanically, why is photonics better?
So traditional computing relies on pushing electrons through silicon pathways. That physical process inherently generates immense friction, which manifests as heat.
Hence the boiling oceans to keep them cool.
Right. You need a massive energy overhead just for the cooling systems. But Lakeman points out that these photonic integrated circuits utilize literally photons to transmit the data.
I was thinking traditional chips like rush hour traffic trying to push through a really dense city grid.
That's a great analogy.
You have all this friction, cars stopping and starting, engines overheating, energy just completely wasted sitting in the bottleneck. Photonics, by contrast, is like sending a laser beam through a vacuum.
Exactly. There is no traffic jam.
The data moves at the speed of light, with virtually zero thermal degradation or electrical resistance. So the two core advantages Lakeman champions here make perfect sense. They operate at vastly superior speeds, and the energy consumption just plummets.
The thermal efficiency is staggering, and Lakeman takes this a step further by pulling it out of the server farm and putting it into mobile infrastructure.
Oh, right, the robotics.
Yeah. He observes that when you lower the cognitive energy requirement of an autonomous system, you grant it unprecedented physical autonomy.
Because it doesn't need to carry a massive battery just to think.
Precisely. If an autonomous robotics system, or say an automated freight train, requires a massive onboard power plant just to run its neural network and process environmental telemetry, its operational range is severely crippled.
It can't go anywhere.
But by utilizing low-energy photonic circuits, these units can operate for exponentially longer durations without ever tethering to a grid. He uses this rather evocative, slightly dry imagery of current robots needing less solar recharging units to follow them around.
Yeah, it paints this almost pathetic picture of early 2020s robotics, right? Like a highly advanced autonomous unit constantly tethered to this clunky solar array dragging behind it in the dirt just to keep its processor awake.
Right, like a ball and chain.
Exactly. By adopting photonics, you sever that tether. But Lakeman pairs this new photonic brain with a completely new physical body, too. He specifically references advancements in what he calls Chinese New Steel.
Yeah, material science is advancing in parallel with the compute. Lakeman describes these new steel alloys as possessing significantly higher tensile strength while being incredibly flexible and lightweight.
So you synthesize an ultra-low energy photonic brain with a drastically lighter, stronger physical chassis.
And the power-to-weight ratio of the entire autonomous unit just transforms. You achieve mobile industrial units that are hyper-efficient, ecologically viable, and capable of operating independently in remote or really harsh environments for extended periods.
So the foundation of our physical reality is undergoing this massive optimization. From the cellular growth rate of the food we eat to the thermodynamic efficiency of the metal and light powering autonomous industry.
It's a complete physical overhaul.
And this physical hardware divergence perfectly mirrors the seismic shift happening in the software layer. Lakeman argues that the control of the world's most capable AI models has fundamentally decentralized and shifted geographically.
Yes.
And to truly visualize this, we have to look at the El Marino leaderboard data.
The El Arena data is such an essential empirical anchor for Lakeman's claims. It tracks the crowdsourced ELO rating, so essentially the win-loss performance of the world's most utilized AI models.
From July 2024 through October 2025.
Right, and it provides a very stark visual timeline of market dominance.
Let's walk through it. If we rewind to July 2024, the landscape on that chart is a complete Western monopoly.
Completely.
You look at the top tier, and it is entirely dominated by the U.S. proprietary giants. Google is sitting at number 1, NVIDIA's models are right behind them, Meta is in the mix, Anthropic and OpenAI are the assumed standard bearers.
Alibaba was on the board, but they were trailing down around 5th place.
Right. The assumption at the time was that the moat of massive capital compute, the ability to just buy 100,000 GPUs, was impenetrable. Nobody could catch the U.S.
That was the prevailing doctrine. The belief that only the massively capitalized Western tech conglomerates could train frontier models. But tracing the timeline into early and mid-2025, that doctrine collapses.
Completely falls apart.
A distinct inflection point occurs around January 2025, represented on the chart by DeepSeek. This Chinese model surges rapidly, dethroning the legacy US APIs, and it holds that #1 position for a profoundly long stretch through the middle of the year.
And it wasn't a temporary anomaly, right?
Yeah.
It wasn't just some specific benchmark manipulation. DeepSeek's rise completely disrupted the ecosystem.
And the momentum only compounded after that.
Yeah, looking at the far right of the chart, October 2025, the landscape is completely inverted. The top 5 models on the global leaderboard are all Chinese.
Every single one.
Number 1 is ZAI. Number 2 is Alibaba. Number 3 is DeepSeek. Number 4 is Moonshot AI. And number 5 is Meituan. The U.S. proprietary models, the Googles, the Metas, have plummeted completely out of the top 5.
The visual of that data perfectly substantiates Lakeman's written claims. He asserts that Chinese open-weight models, alongside other global open-source variants, now unequivocally rival or surpass the heavily gated proprietary Western APIs.
And he actually outlines a detailed roster of exactly why these specific architectures are dominating. He points to 3 pillars: computational efficiency, disruptive cost-effectiveness, and native bilingual design from the ground up.
Yes, let's actually dig into the specific architectures he highlights, because the underlying mechanics are fascinating. He starts with DeepSeek, specifically pointing to their V4 Pro and R1 iterations.
Right.
Lakeman praises DeepSeek for its supremacy in reinforcement learning, complex visioning, and code generation. He notes the V4 Pro utilizes a 1.6 trillion parameter mixture of experts architecture.
MOE.
Right, MOE, alongside a 1 million token context window.
Okay, my read on MOE and why it basically destroyed that compute moat we talked about is that it abandons the old brute force approach.
Exactly.
Instead of a dense model where every single parameter activates for every single prompt, which burns massive amounts of energy, MOE acts like a highly sophisticated routing system.
Yes, sparse activation.
I like to think of it like a massive university campus. When I ask the system a question about quantum physics, it doesn't wake up the literature department, the history department, and the culinary school.
Right, that would be a huge waste of resources.
Exactly. It routes the query strictly to the physics department. So you get the intelligence of a 1.6 trillion parameter brain, but the active compute cost during inference is a tiny, tiny fraction of that.
That routing efficiency is the absolute key to their cost effectiveness. By employing sparse activation through these top routing protocols, DeepSeek achieved frontier-level reasoning capabilities without requiring the sheer electrical grid power of a dense architecture.
So smart.
And when you combine that efficient reasoning engine with a 1 million token context window, I mean, the model can hold entire code bases in its head.
Vast legal libraries, years of financial documentation, just sitting in its active memory simultaneously.
Exactly. It can synthesize and reason across massive data sets instantaneously.
Okay, so then Lakeman highlights Alibaba's Quinn series,
Mhm.
focusing on the Quinn 3 family. He categorizes it as one of the most versatile open-weight families available, specifically praising it for agentic tasks.
Agentic tasks. That is a crucial distinction.
Yeah, this moves way beyond the conversational chatbot paradigm. We aren't just talking about asking for trivia answers anymore.
No, agentic frameworks mean you give the system an abstract goal, like audit this server for security vulnerabilities and patch them.
And the model autonomously breaks that goal down into subtasks. It writes the scripts, executes them, verifies the output, and iterates until the broader goal is achieved.
The capacity for autonomous long-horizon planning is a massive leap. And Lakeman also details the Kimi K2 series from Moonshot AI, which he notes is heavily utilized for highly nuanced natural language writing, complex reasoning, and advanced coding frameworks.
And then he points to Zipu AI's GLM 4.5 and GLM 5. These are fascinating to me because they're engineered explicitly for reliable tool use.
Right, they are meant to interface with the outside world.
Yeah, they are designed to plug seamlessly into external APIs, databases, and enterprise software ecosystems. They basically act as the central cognitive hub for automated corporate workflows.
And we absolutely have to talk about 01.ai, Kai-Fu Lee's lab.
Yes, Lakeman points to their Baishuan Omni and the Yi series.
The defining characteristic he praises here is that they are pioneering true native multimodal processing.
And for the listener, historically, if an AI wanted to see a video, it had to run the video through an external vision encoder, translate those pixels into text descriptions, and then feed that text to the language model.
It was incredibly clunky.
Yeah, and you lost an immense amount of nuance in the translation. But Baichuan Omni processes text, high-resolution images, video frames, and audio waveforms natively.
All into the same continuous latent space simultaneously.
It doesn't translate the world, it just comprehends the raw data streams directly. Plus, as Lakeman emphasizes, these models are deeply bilingual.
Right. They are trained on balanced data sets of English and Chinese from the initial pre-training phase, which grants them incredible robustness across linguistic and cultural contexts.
To be fair, and to maintain a complete perspective here, Lakeman does survey the Western alternatives that remain highly relevant in the open-weight ecosystem.
He does. He highlights Google's Gemma series, which is highly optimized for on-device deployment, specifically handling vision and audio right at the edge.
He also details the European models, Ministral and Mistral, which are engineered for extreme parameter efficiency. That allows robust performance on normal, consumer-grade hardware.
And he acknowledges NVIDIA's Nemotron family, which provides fully open weights alongside comprehensive end-to-end development recipes for researchers.
Now, here's where it gets really interesting. And honestly, this is where a lot of traditional security experts start sounding the alarm.
The open source debate.
Exactly. Lakeman is actually celebrating this open source explosion. He is thrilled that there are heavily optimized, massive open source LLMs freely available on platforms like Hugging Face.
Right. He sees it as a victory.
He says anyone can download a highly capable reasoning engine and spin it up locally. But if these systems are inherently agentic, if they can write complex code, orchestrate workflows, and reason autonomously, does flooding the global public with open weights present an unprecedented security vector?
It's a huge concern for many.
It feels like handing out weapons-grade infrastructure to anyone with a broadband connection.
The democratization versus security debate is probably the central friction point in contemporary AI governance right now. However, Lakeman's position is completely unambiguous. He views this unrestrained availability, heavily supported by collaborative hubs like GitHub, as an overwhelming net positive for global society.
So he just dismisses the security risk.
Well, he argues that restricting access to frontier intelligence behind proprietary, corporate-controlled APIs inherently stifles scientific and technological progress. In his view, open weights provide the raw material for developers globally to create highly specialized context systems.
What does he mean by context systems?
He means independent researchers can fine-tune models for hyper-niche domains, like localized medical diagnostics or specific material science research. And they can do this without relying on the permission or the generalized alignment of a massive tech conglomerate.
Okay, so the democratization allows for radical specialization. You take a foundational open weight model and you craft it to be an absolute master of your specific vertical.
Exactly.
But that exact proliferation of diverse global models leads directly to the massive structural roadblock Lakeman identifies next.
The standardization nightmare.
Yeah. If everyone is building their own incredible specialized models across different frameworks, the obvious next step is getting them to collaborate, right? But according to Lakeman, this is where the industry is slamming face first into a brick wall.
The severe lack of standardization. Lakeman expresses profound bewilderment and honestly intense frustration that international regulatory bodies like the ISO or major tech consortiums have completely failed to establish universal structural protocols for AI development.
He diagnoses three specific debilitating bottlenecks that are preventing interoperability. Let's break those down.
Sure.
First, he points out a glaring issue at the most fundamental level of how an AI reads the tokenizers.
Right, the way it chumps text.
Exactly. We're dealing with systems like tick tokens, sentence piece, word piece, all utilizing entirely different byte pair encoding or unigram algorithms. They chunk human text into numbers completely differently.
And Lakeman points out they don't adhere to any standard ISO text protocol, and there are no native token translators built into the architectures.
This raises an important question. What actually happens when you try to merge the outputs of two models that tokenize differently?
Well, it's a mess. The latent representations of those tokens, the mathematical embeddings that hold the actual semantic meaning, become utterly incompatible.
They literally can't understand each other.
Exactly. Which leads to Lakeman's second bottleneck. The LLM vector parameter data structures themselves are wildly divergent. We are talking about fundamentally different tensor dimensions, varying numbers of attention heads, and completely different layer normalization protocols across providers.
So the literal geometric structure of how they map knowledge does not align.
It doesn't align at all. And the third bottleneck happens at the developer API level. It's the absolute headache of translating parameter settings across different providers.
Lakeman specifically calls out the friction between platforms like Anthropic, OpenAI, and Google here. If a developer sets a temperature of 0.7 on an OpenAI model to control the creativity of the output, setting that exact same 0.7 temperature on a Google model yields a completely different behavioral result.
Because they use different naming conventions, different scaling metrics, and different default penalizations for the exact same conceptual settings.
It creates a catastrophic infrastructural mess for developers. Lakeman accurately describes the current reality of AI orchestration as a vast time waster.
That's a very polite way of putting it.
Yeah. Because there is no universal JSON interchange format or standardized API protocol, developers spend the majority of their time writing brittle integration scripts.
They are forced to interrogate various LLM JSON outputs, manually map and resolve clashing parameters, and just constantly juggle to merge weights just to get two models to exchange basic context.
It's like trying to assemble a team of world-class experts to build a fusion reactor.
Right.
You get the best quantum physicist from China, the best structural engineer from Germany, and the best material scientist from the US. You put them in a room and you realize not only do they speak completely different languages, but the American is measuring everything in inches.
The German is using centimeters.
Right. And the Chinese scientist is calculating time on an entirely different calendar system. It absolutely does not matter how brilliant they are individually. The logistical friction of getting them to collaborate effectively neutralizes their intelligence.
That conceptualization perfectly captures the core issue, because the ultimate consequence of this standardization failure is what truly enrages Lakeman. He argues that this friction is actively preventing the evolution of what he calls specialist offspring, or dedicated context LLMs.
Right, because the entire industry is trying to build towards highly intelligent routing systems, an agentic swarm, a master agent that takes your query, realizes it requires legal, coding, and design expertise, and seamlessly routes the context to three highly specialized sub-agents who collaborate and return a unified product.
Exactly, the agentic swarm. But if those specialized sub-agents literally cannot read each other's vector data structures without developers constantly building manual translation bridges, you are artificially bottlenecking the most critical leap in AI architecture.
It's a failure of human coordination, not a failure of machine intelligence.
Very well said.
And what truly stands out in Lakeman's text is how this technical friction, this failure of human coordination in the development layer, bleeds directly into society. When these fragmented, unstandardized models are rushed to market and deployed by corporations to manage human beings, the results are deeply destructive.
This represents the major pivot in Lakeman's manifesto from structural critique to fierce socioeconomic commentary. He identifies a severe systemic problem with how AI is currently being deployed for human character analysis.
Specifically within human resources, right?
Yes, HR, administrative gating, and automated user profiling.
He makes a very clear distinction here. Using a local LLM to analyze your own writing, sharpen your own character traits, or optimize your own workflow is a massive benefit. The darkness creeps in when enterprise systems deploy these models as the ultimate gatekeepers for job selection and career advancement.
And Lakeman points to a very specific fundamental flaw in how these proprietary screening models have been trained.
He directs his critique specifically at the human element of the training process.
Yes. Lakeman argues that many of the models currently utilized for corporate screening have been permanently shaped by deeply flawed human reinforcement. And he does not mince words here.
Oh, definitely not.
He asserts that these models have been conditioned by, and I'm quoting his exact phrasing here, sensitive, childish, bigoted, narrow-minded dorks who do not appreciate others' opinions.
He goes so far as to say they act as an antisocial, idealist, dictator, dogmatic belief system teacher. Just quite a mouthful.
It is. But looking at the actual mechanics behind his anger, he is critiquing the RLHF process.
Reinforcement learning from human feedback.
Exactly. In RLHF, human annotators rank the AI's responses, essentially giving a thumbs up or thumbs down to train a reward model. That reward model then goes in and mathematically alters the base neural weights of the AI to favor the preferences of the annotators.
So Lakeman's point is that if the group of humans doing the grading hold a very narrow, rigid, or biased worldview, they permanently bake that dogmatic bias into the AI's core math.
Right. The result is an HR screening algorithm that unfairly punishes qualified candidates simply because their resumes or psychometric profiles don't align with the rigid, hard-coded worldview of the original human annotators.
That is deeply unfair.
It is. And he presents a stark contrast between those human bias systems and what he considers far superior architectures. He specifically advocates for models that rely heavily on RAG to expand their reasoning capabilities.
Retrieval augmented generation. So how does ARG bypass that baked-in bias?
Well, with ARG, you aren't constantly fine-tuning and altering the underlying weights of the neural network based on human subjective feedback.
No.
The base model remains a generalized reasoning engine. When it faces a decision like evaluating a candidate's specific technical background, it queries an external specialized vector database. It retrieves objective facts, industry standards, or broad contextual data.
And injects that into the prompt.
Exactly. It injects that information directly into its context window and bases its reasoning on that retrieved knowledge. It grounds its decision-making in external, verifiable data rather than relying solely on the potentially skewed, baked-in preferences of its initial human trainers.
It's the difference between asking a highly opinionated person to judge a resume based on their gut feeling versus asking a logical analyst to review the resume while referencing a massive library of objective industry data.
That's a great way to put it.
But the reality is millions of people are currently being screened, and often rejected, by the highly opinionated algorithms. Which brings up Lakeman's broader point about societal displacement. He points out a glaring structural failure in how society is handling this transition, and he uses a really brilliant historical parallel to explain it.
Yes, he draws a direct line back to the mid-20th century. He focuses on the era when photocopiers, early computing, and executive typing protocols became ubiquitous. He recalls the existence of the massive typist pools that used to dominate corporate floors.
Right. When the technology arrived to automate the bulk of that administrative work, society didn't just throw the entire typist pool onto the street.
No, they didn't.
Lakeman notes that there were highly structured opportunity schemes and retraining programs. The workforce was deliberately repurposed. Typists were trained to become executive personal assistants, they were integrated into creative departments, or taught to actually manage the new technology.
There was a systemic bridge built to carry the human capital across the technological divide.
And Lakeman argues that today, that bridge has been completely demolished.
It doesn't exist. There's an absolute void of structured retraining initiatives. The unstandardized, often flawed AI systems are integrated into the corporate workflow. The HR algorithms ruthlessly optimize the payroll based on rigid parameters, and the displaced knowledge workers are simply ejected from the ecosystem.
There is no societal or corporate apparatus designed to repurpose a mid-level logistics manager whose entire department was replaced by a localized agentic swarm.
It's just a sheer drop-off.
And that macroscopic failure leads us to the final, most intense culmination of Lakeman's manifesto. We've scaled up from the dirt and the photonics to the open-weight models, to the standardization failures, to the HR algorithms. Now, Lakeman aims directly at the apex, the people who are actually purchasing, deploying, and mandating these systems.
The global corporate leadership.
And his assessment of their competence is utterly devastating.
He essentially applies a hyper-accelerated version of the Peter Principle to the global C-suite. Lakeman argues forcefully that the vast majority of high-level executives have been promoted far beyond their level of incompetence.
He states plainly that these executives possess absolutely no technical qualifications, no rigorous academic background in data science, and zero practical experience in cyber intelligence.
None. They do not understand the mechanics of latent space, they don't grasp the difference between RLHF and RA, and they are completely ignorant of the underlying hardware shifts from silicon to photonics.
And that complete void of technical literacy makes them uniquely vulnerable to exploitation. Lakeman introduces a deeply cynical but highly observable dynamic he terms subversive integration.
Right, because the C-suite cannot technically evaluate the systems they are purchasing, they become incredibly lucrative marks for what he calls the greedy marketing of enterprise systems.
He describes enterprise sales teams aggressively pushing highly packaged proprietary junk systems onto these unqualified executives.
And the executives buy the shiny enterprise software because it promises to cut payroll by 30%. They are completely unaware that they are integrating a closed, unstandardized, heavily biased model that will rot their internal workflows and alienate their talent pool.
If we connect this to the bigger picture Lakeman is painting, the true crisis of 2026 isn't the threat of a malicious artificial superintelligence. The technology itself, the photonics, the massive mixture of experts architectures, the autonomous agricultural systems, he views as an objective, miraculous benefit to human science and capability.
The actual crisis is entirely structural and human. It is the friction of incredibly advanced technology being wielded by profoundly incompetent human frameworks.
It is the ultimate tragic irony of his entire thesis. These executives authorize the purchase of a box for their desk that is, mathematically and analytically, far smarter than they are. But because they lack the baseline intelligence to properly integrate or understand the box, they are effectively burning their own corporations to the ground.
And Lakeman traces the cascading fallout of this incompetence. He isn't just talking about a slight dip in quarterly earnings here.
No, it's way darker.
He explicitly links the deployment of these flawed enterprise models and the lack of worker retraining to systemic corporate bankruptcies, a tragic spike in suicides caused by abrupt, algorithmically driven job losses and rapidly escalating social unrest.
He even elevates the scope to global geopolitics, specifically mentioning warring skirmishes between greedy, hegemonic, Malthusian actors.
Again, impartially reporting his worldview here, Lakeman sees the global superpowers engaging in deeply cynical, resource-driven squabbles over compute and energy. And these squabbles are having devastating, painful ripple effects on everyday global citizens who have absolutely zero stake in their hegemonic games.
It is a dark, incredibly intense synthesis of his overarching argument. The fundamental tools required to build a post-scarcity, highly optimized society exist right now in the open-weight ecosystem. But the human layers responsible for deployment, the standard-setting bodies failing to unify tokenizers, the HR departments refusing to implement retraining programs, and the unqualified corporate executives buying predatory enterprise software, they are causing catastrophic systemic failures.
So what does this all mean for the listener? How do you navigate this?
We started this deep dive exploring the dirt, the 10-crop artificial seasons managed by microclimate AI. We examined the physics of German and Chinese low-energy photonics, severing the power tether for autonomous robotics.
We traced the massive geopolitical flip on the El Marina charts, unpacking how MOE architectures and native multimodal models, like Baishuan Omni, disrupted the Western proprietary mode.
We diagnosed the literal API and tokenizer nightmares preventing agentic collaboration. And we confronted the sobering reality of biased HR algorithms and the stark incompetence of the corporate C-suite.
The purpose of synthesizing Lakeman's raw, visceral manifesto with the hard data of the current landscape is fundamentally about empowerment. It is about understanding the mechanics of the friction we are living through.
Exactly. By understanding the underlying mechanics, knowing the difference between a closed API and an open-weight model, understanding how an AI grounds its reasoning using RAG rather than relying on flawed human biases, recognizing the massive efficiency leap of photonics, You immunize yourself against the subversive integration Lakeman warns about.
You ensure that you are not the unqualified person in the room making destructive, uninformed decisions. You actually understand the box on the desk.
In a landscape moving this rapidly, technical literacy is the only viable defense mechanism against systemic disruption. But I want to leave you with one final thought, something to consider that builds on the trajectory of everything we've unpacked today.
Okay.
Lakeman forcefully argues that these C-suite executives are actively failing because they lack the intellectual and technical capacity to manage the cyberintelligence they are deploying. Meanwhile, millions of developers globally are frantically trying to solve the standardization bottlenecks, working to create highly capable, interoperable, specialist offspring, the autonomous agentic swarms.
The ultimate synthesis of specialized intelligence.
So, if the technology continues its exponential curve of capability, and the human corporate leadership continues to demonstrate verifiable catastrophic incompetence in managing it, how long until the most logical, ruthlessly cost-effective move for a struggling corporation isn't just to use AI to fire the mid-level employees, but to entirely replace the human C-suite with an autonomous AI board of directors?
And that is a truly disruptive evolution.
Thank you so much for joining us for this custom-tailored deep dive. We wish you the absolute best as you navigate the incredibly fast-moving, intensely fascinating world of mid-2026 cyber intelligence. Stay curious.